Hello students, good afternoon. In this session I am going to explain you how to run a Perl programming in the command line and the procedure in Windows system and Linux based systems. If you want to practice Perl in your systems, most probably I hope you all have Windows based systems. So you have to download first the Perl, right? So this is my video for that. Perl. Perl, you can go there and you can download the Perl. After that, you can choose the version and variant of depending upon your system. For a Unix machine, you can download from here. For Windows, they have given two types of Perl. One is Strawberry and is active state Perl. Mostly active state Perl will be advised to install. Personally, I like Strawberry Perl because it has warnings will be less. So I can download this thing. I can just you can just click it and you can proceed the download. In my case, in this system, I already downloaded and installed. So you can go and download. After installation, let you know how to work, right? So this is about Perl installation in Windows and Unix system. You can download from here. Suppose if you are using Unix laptop based on Linux means. Okay. Now after installation, you can find command line of Perl in this Windows, right? So you just click and see where it is the working space. So users laptop in the C drive, users laptop name, then documents. So the first thing is all the program files should be available in the documents, right? Suppose the program coded files you saved in the desktop and you are like to work in the Perl means the Perl doesn't respond. So note the point, the documents. So all the program scripts or program files are files which are going to be executed in the command line should be in the documents, and this is the first condition. Now we can uh, check whether Perl is installed here. What is the version of the Perl, right? Perl space -v, just give an enter, it will give the okay, the Perl is installed, the version 32 version subversion. And one more thing I forgot, and even Strawberry or active state of Perl, you should choose your appropriate bit, mostly 64 bits. All the systems nowadays are 64 bits. You should choose a 64 bit .exe file from the Perl, right? For installation. And good. Next we will see how to write a program and how to run it. And first thing is, I already made for you some scripts for that, for the different purposes. I will say anyone, right? Okay. The first thing is you should, and this is trans. Trans means I give a file name as a trans for my purpose, and this is for translation of DNA into RNA, I think. So first you have to open a text file and you have given all the commands in the text file, right? So this is the text file. I have given commands which are all executable by Perl. in the command line, right? So hash, you should memorize the first line and write, okay, hash exclamatory and user bin Perl. So hash means we already knew that after the hash, whatever you write, it will not take as a command, right? So we can use hash anywhere in the line and we can write anything. It don't disturb Perl. Okay, most probably we use hash for information or sometimes tutorial purpose. Suppose I can write here hash, this is a DNA, like that. Okay, okay, the first thing is in the first line hash user bin Perl, and the next we are going to convert DNA into RNA, right? This is our task. The task given is convert DNA to RNA. So for that, first we need a DNA sequence. So I have given $DNA equal to, right? Kindly note it down. This is scalar variable. So we have to use this dollar symbol. Then name is DNA. This is, we have given that, assign that DNA name, and then equal to, you should use double quote. Wherever you assign, you should use double quote. In between that you can write anything to assign, right? Here the sequence in the double quote, and all the Perl program should end with semicolon, right? You already knew that. That is the second rule for that. So print DNA sequence is, so this is the command. We have assigned the DNA equal to this sequence given, template given to you, or you can type as such whatever you want, type. So now $DNA means this sequence. Then we are asking the Perl command line print that sequence, right? So print DNA sequence is, which means print it. First line should be, it shows DNA sequence is, it ended with semicolon, right? Note it down. This also in the inverted commas in between the inverted double quotes. Okay, then in the second line print $DNA new line, right? This is print, first print is DNA sequence is, so it shows in the black screen DNA sequence is, and the next print is, after that following by this line, the next print is the sequence which are given here, right? We assigned the sequence equal to $DNA, so $DNA, then new line, then semicolon. That's all. Okay, the next is we have to convert, right? So RNA equal to, we have given a new name, this RNA, which is equal to DNA, whatever we used here, DNA. Then again we are telling that RNA equal to substitution of substitute. This is the operator, substitute that with wherever the T is there in the sequence, those are all should be converted into U, right? So this is G. G means global. Global means everywhere in the sequence, right? So that's G should be used. Okay, this is substitution, this is operator, this is substitution, yes. Then this is the base what we are going to change, and this is the base what will be getting into. T became U. If you write this code, T became U, and G is for entire sequence, global. That means global. It continues up to the document end. Okay, nice. Then print here RNA sequence. This will be the first one, and second one is print this RNA. Okay, this RNA. So now we convert this DNA into RNA. This is about the code for Perl, right? The command for Perl. Now we can see how to run in the command line. So what you did, you open a new text document, new text document, like that, and you can write the commands Okay, and saved. Is it? And saved where it is, that is trans, right? This is a text document. Text document won't run in the Perl environment, so we should uh, change the txt into .pl. You click there and you can go .pl, right? So you can just give OK, enter, and give yes. See that trans.txt became trans.pl. Okay, so at the first you open the text file, notepad file. In the notepad you write all these commands, whatever you want to run, save it. While saving, change the file extension name, right? .txt should be changed into .pl. Okay, the .pl only identified by the Perl program. Okay, now what I told you, this file is in where it is in the desktop, right? I have saved this in the desktop. The first condition is if a file should execute means it should be in the same folder, same place, right? So Perl is in the document, in the documents folder, a document. This is the path. So I can change, I can copy this trans.pl into Control C, and I can go for the document here and just paste options. So I can use Control V. Okay, now you can see I have the Perl file in this trans Perl file. Whatever I showed in a text file, now I convert into the PL file and saved in the documents because Perl is running from this folder. Okay, Perl access this folder. Okay, now you can go open the terminal and just type the name of the file. Say this trans.pl. So I will type trans.pl. So we already given the codes here. This file will be just execute and show the result. Okay, and say this, enter. This is opening. Okay, trans dot pl. Last time I used a shift, mistakenly I used a shift, that why the file opened. Now I give enter. What happens? Something went wrong. Why trans.pl only is there? It won't actually. Trans.pl. So it doesn't like that. So wait a minute. I will see what happens. So I found that the reason why it is not opened, the reverse.perl and the trans.perl, those are the two files present in the documents. Those are defaultly opened by Notepad, right? If you use open with Notepad and always means it will not run in the Perl, right? You just give us a Perl interpreter, like choose another, then give Perl interpreter always, right? If you use Notepad for always means it will open in the program separate window. If you select interpreter means for the first time it is not happening. Suppose if you are opening the file always with Notepad means this will happen. Okay, so just to do it as such defaultly. Okay, now I chose Perl interpreter always. Okay, then now you can see that reverse.pl is a Perl program file. Perl program file. So now it will be work, I think. You can go there, and I have already checked this. Okay, so I will close and I will perform again. Okay, this is document. I already transferred the document from the desktop to the documents, right? And trans.pl. So we will go that trans.pl. See this? The first line is DNA sequence is the given one. Then here is RNA sequence. That's also given one, right? So how the commands reply to this? We will see that trans, right? I will open with, now I can give open with notepad, right? It is open in the notepad. So see the command executed. Compare this. Hash user bin Perl is as usual normal. We have to give us a header line. And the second thing is DNA sequence. We have assigned $DNA sequence I have given. The print, first line print is DNA sequence is. See this DNA sequence is. This is the first line, right? And colon is there. Here also colon is there. And the next is print DNA as a new line. After that, new line, print DNA. DNA has given. After that, only new line. Suppose I can give here a new line also. See that? First, observe the difference. Here there is no new line, so it comes as a single one, right? DNA sequence is this thing. Okay, and print DNA new line. After that, after this line, new line will be coming, and here RNA equal to sDNA, same thing, and RNA equal to substitute T into U, and it will be for global, right, for all the entire sequence or the entire document like that. So print here is RNA sequence. See this, here is RNA sequence, colon, and print RNA. So all the T will be converted into U. See. So this is the use of Perl in bioinformatics. This is one of the use, a simple example for you, for your understanding. And you can see this, suppose DNA sequence is, maybe I given a separate line. So I will enter here a new line, right? I can save, and here also I can give the new line. Okay, I can save this. See this, in the first file DNA sequence is the sequence displayed in a single line, and here is RNA sequence, and that also displayed in a single line. What happens now, we have given the two new lines. The first line will be DNA sequence is, then the sequence starts in the second line. See this, now we can trans.pl, enter. See the difference. I hope you understood. DNA sequence is, I have inserted new line there, so it comes in the second line. Here is the RNA sequence, and it comes in the second line. And this is how Perl can easily work with a Word file. It is extraction language, right? So it is very easy to work with that. So likewise, whatever the task assigned to you, you can create a notepad first, text file first, then text file should be converted into .pl. The .pl file will be executed. Just type the file name and that file will be executed. Okay. For the example, I will show you what are the important or basic bioinformatics applications of Perl. So this is text again. So you can open, say this. I have named is concatenation. Concatenation is the process of joining the two documents or two sequence or two lines, whatever it may be. And so DNA 1 is there. We have already given the sequence, and DNA 2 is there, right? See this line you should memorize and put. And the second one, most important thing is you should use inverted commas, those double quote. Okay, inverted commas, and it should be end with semicolon. Don't forget this semicolon. So DNA1 we have assigned something, and DNA2 we have assigned one more thing, and print. The first print is coming. First print DNA1 new line, right? And the print the second print DNA2 new line, next is space. Okay, you can omit this also. You can just give new line, that's enough. But here we need a space, means we can give another new line. Then the DNA3. Now come to the point. We need a concatenation sequence, which means we are going to join the DNA1 and the DNA2 sequence as a single one. So that is we have assigned DNA3. In the DNA3, DNA1, see this inverted commas and double quotes inverted commas, and here DNA1, and without space you can write $DNA2. So $DNA1 will be obtained from here, $DNA2 will be obtained here, and this is assigned the two sequence. The thing is, you can use for concatenation, you can use dot operator also. If you use dot, the same results you can get. Without dot also you can get. Okay, then we will see that is it working. And that, so print DNA3 new line. Okay, that DNA3 will be what concatenation. DNA3 we have assigned, right? Here we have assigned DNA3 is DNA1 and 2. So print DNA3. This DNA3 will be the single line. Okay, we will see. And this is in text format. Again, you have to change into .pl, and I did nothing, right? Don't say. Okay, so I will copy. First I have to go to documents here. In Linux system, you should see where the Perl is working space. Uh, working from that folder, you should save all the Perl commands. For example, here we are using documents, right? In Linux, this may be in a different place. You find that and save all the Perl scripts in that particular folder. Then only Perl will execute those. Okay, come to the point. And here I have transfer the document into transfer the Perl script into document folder, and this is still it is in txt format. Then I have to change, double click that, and you can change, single click that, you can edit option by using single click. So I can use Perl PL and just enter. It gives yes, I will give. Now we can execute in the command line concatenation.pl. I will go there and use concatenation.pl, and you can just enter. See this? I will open side by side. I will open this also. Okay. The first DNA is print DNA1, and this is the concatenation. Print DNA1 is printed, and second print is DNA2 is printed. See, after that one gap is there, that is the second new line. So this is the new line, so the space is created. If you omit this n, means this space will not be available. for you. And the DNA3 is concatenation of the two, so the entire sequence is in the single line, right? Easy, right? So it will work like that. We will give in the last experiment we have seen that here the DNA is, here the RNA is, like that. Here also you can give like print the DNA1 is, and here also print the DNA2 is, then print DNA3 is, like that. You can, whatever you want, you can write in the text file and convert it into .pl, and you can execute in the command line. Okay, this is how Perl working. And now I will explain the programs command lines, program scripts, how to, what is the reason for the, what are the operators, what is the reason for using those operators in the script. Okay, so for my purpose I am using Perl tutorial. We have already seen the concatenation, right? Concatenation means nothing but joining, appending the two things. And gc count, see this will be an tedious one. .pl file I will open, right click and open with notepad, and please listen carefully and do that. We are going to find the how much amount of GC is there, and what is the percentage of GC, and what is the number of occurrence, ATGC occurrence, right? And for that, here as usual we can start with um, this hash user bid Perl. The next one is we have to assign the sequence. This may be in a given sequence, or you can write it your own, type it there and your own. And one more option is there. If you are using stdin, there is a command in that. Stdin means standard input. So that allows user to input the sequence, right, in the black screen command line. Okay, done. This is $DNA equal to something, and I want to know the length of the sequence. So dollar length is the function, again len, it gives length and open the bracket, that is the thing. In the function you have to open the bracket and use what you are assigned, length, and open the bracket, parenthesis, and DNA, and close it, then exit by using semicolon. Then you have assigned two things. And what is the print? Print in a new line, DNA length is, right, semicolon, DNA length is a, will be appear, this sentence will be appear in the command line black screen, right? After that, this colon, by the continuous, the length will be appeared, then it goes to new line. Okay, this is how to find the length of any Word document or sequence or genome, protein sequence, genome sequence, everything. Okay, now suppose if I want to know how many characters are there in that, different characters. For example, in DNA we have adenine, guanine, thymine, and cytosine. I want to know how many adenines are there, how many thymines are there, how many cytosines are there, like that. So I have assigned first a scalar. Number is the function, G is the character in the sequence, equal to 0, which means this variable converted into the number, the first is 0, so we are initiating equal to 0 from the 0. So likewise guanine, cytosine, thymine, adenine, so all the will ended with all the comments ended with semicolon. So then after that come to the array at basis equal to, this is the new one function you called at basis equal to, split the DNA in, split the DNA, which DNA we already assigned as a dollar DNA here, split that. After split you can call the for each, right, for each function. Then we have created the new one, which means base pair, BP, at the array. You should write in the notebook and to understand all those things and try to execute the program, right? So for each loop, we are searching a base pair in the bases array of bases, right? So open the subfunction. If the basis is the operator equal to operator matches G, I is an integrated operator. It continues by adding 1, 2, 3 like that. You can use square also. Likewise, it will be increment. I means increment. Increment is given increment. So matching M, and this is G. Whatever you may put A, T, G, C, anything, anyone, and is I. Close the bracket. Right. This is the sum function in the bracket. After that, open that another bracket and see the number G plus how many it is. Right. This will find the matches of G, and this will count how many count is in that, how many count is matching, like that. Okay, so likewise you can go for guanine, cytosine, thymine and adenine. So close the bracket. After closing, then print new line number of G bases. So G will be here, right? Print new line number of G bases, and then number of G bases equal to whatever the number you have given is there, right? So number of CT like that. Don't forget to use semicolon, all those things, and everything you should use new line, new line, new line, new line. You can give new line in the end of the function also, end of the line also. So this is, it will, okay, where I was. Here for each, then basis will be from the array, we can get from the array, and you have checked the how many matches are there and increment by counting the matches, and print number of G how much, number of C how much, you can call that dollar number G like that. So this is one task is over. The first task you can find the length of the given DNA sequence, and the second task you can find how many occurrences are there, ATGC are there, and the third task is what is the GC content of that. So you can call GC content equal to, open the bracket, and number of G plus number of C. It will be from number of G, number of C. This is actually from here, number of G and number of C will be here. This will be incremented and calculated. Then you have to divide this total by length of the DNA, right? So we already have find the length of the DNA. We already defined the length of the DNA. So length of the DNA into 100, right? See that you have to open the bracket here and close it for the function, and close it, the one another bracket is close for the entire function, and into multiply into 100, close it by using semicolon. Now print new line, two new lines, GC content is, this will be appeared, this sentence will be appeared in the black screen, and GC content percentage also. So this is the program. Kindly go through it, kindly observe closely and write it down. Understand this, you can write it very easily, right? So can we run this GC count in a command line? Okay, first I have to copy this into documents, sorry, documents. So I will paste here. So already gc count.pl, so no need to change anything, the extension. if I directly go to the command line and gc count.pl, right? So gc count, the file name whatever you want you can give. Okay, uh, g count actually, so be careful on typing this g count.pl and just give the enter. See this DNA length is 31 bases are there, and so we will see, open with notepad. This is the command you have given, and this is the command you have given, and this is the result. See that the first print is new line. What happens? It gives space, right? DNA length, print length DNA length is, so then DNA is 31. So see this, the first n gives a space before the line, the last n give the space after the line. Okay, these are the thing. And see that next print where it is, the first print comes and next print is here, print, space will be there, number of G, right? Space will be there, after that space given, number of G equal to 7, number of C equal to 6, number of T equal to 8, number of A equal to 10, like that you can. After that, and the new line, space given, right? This will be considered as a single one. So the space will be given the before and after the commands. So say this, before space is there, after the space is given, and the gc content equal to gc content is, see, next print is two new line option given in that, so the space is given here, and gc content percentage, gc content is how much, 41 percentage. Gc content, sorry, here I have to write percentages, I missed to write gc percentages, then new line. Okay, gc content percentage, then new line. So 41 plus part 41.9 percentage is available, this current is available in the given sequence. This is how we can find, we can analyze the sequence. In this example we are using very simple shortest sequences, right? Really genome is very bigger, lengthier, so for those purpose Perl will be very easy to handle the text, handle the words or strings, right? uh, the next one I will show you. So GC concatenation, then this is protein sequence, already in text format. Just I show you what is there in that. Suppose we have a FASTA sequence, suppose we have a gene sequence or protein sequence in a different file, which is not in .pl, right? And different file is just we downloaded from the database, means we can open that file as such. And the thing is, see that this is the first line as usual. Well, the second one, whenever you use hash is nothing, right? This is not going to take as a command by Perl. So you can use read protein sequence data from, this is the information for us, what is going to do, like that, information for the user, or tutorial something informations like that will be given. So command start here, yes, protein file, dollar protein file, we have to assign dollar protein file equal to sequence.fasta. The sequence.fasta is a file which is I downloaded from the Uniprot or NCBI whatever, right? This file also available in the document folder, and that is more important. Whatever the file open, if you want to open through the Perl, you should confirm that all the files and folders in the uh, space or in the path or in the folder where Perl is working, Perl is there. Okay, so sequence dot faster. So the next one is, see that there is no command, print protein file. This may be an see that this is the again assign dollar protein equal to protein file. So next is print. Here is the protein and double new lines and print protein exit. Okay, this is how we can show the downloaded files. Instead of sequence.fasta, you can give anything, the file name or file number, whatever the file name is, right? For your own, you can change this and you can run. You can open the file. I'll just show you how it is working, right? Sequence.fasta is not in this system. Sorry, I cannot run because see, we need sequence.fasta file, right? For that, we need sequence.fasta file in the uh, documents folder, and here in the documents there is no FASTA file here, so I cannot open. That is actually in the different machine, so I forget to copy that file. So I may download from the internet now itself, but the time consuming on. Okay, next we will show. I believe that you understood the concepts. And the next example is protein sequence. Reverse we already uh, done, I think. Reverse means DNA reverse complementary sequence. The sequence will be given to you and you got to make a reverse complementary DNA. The first, as usual, write this word and then assign a DNA. This will be given to you, or you have to write your own sequence, or you can use downloaded sequence from the NCBR Uniprot, right? Then print DNA sequences is okay. You can print. This will be printed in the black screen, and after that line, new line, this will be comes. Okay, print. Then this is the function reverse complementary, REVCOM, the reverse complementary, reverse DNA. Okay, see that DNA is already there. Yes, $DNA we have assigned that. Print we already given for the print. The next one is we have to make a reverse. For that first we can make the reverse complementary, so reverse DNA. After that, the reverse DNA we need to make as a complementary base, right? In this command the DNA get reverse. After that we have to make complementary one, like C is complementary to G is complementary to C, A is complementary to T, like that. So we can use those command also. Reverse complementary equal to TR, transfer, transform, right? And the operator equal to transform A into T, C into G, G into C, then at last T into A. And this single command is enough to convert all the bases into their complementary bases. So as usual, you can end with semicolon. Now print reverse complementary sequence is, this will be printed in the black screen as a sentence. After that, print reverse complementary. The reverse complementary means this will work out and it will give. You want to see that? Okay. Then I will execute this file, reverse.txt. So I just reverse.txt is already in the document file, I think. Is there reverse.pl. So I can and just open the command line reverse reverse dot pl. Just enter. See that DNA sequences is. So I will show you. Where is that? This is the text file, and this is the result of that. Oh my God. Now you can compare this. Okay, DNA sequences. The first print is DNA sequences as such, it comes here, and the second print is DNA new line. This is what we have given as a sequence, and the third print is reverse complementary. Reverse complementary sequences is okay. Reverse complementary sequences is GC. It converts. It is the it is complementary, right? The reverse, right? So C is complementary to G, and G is complementary to C, and here A is complementary to D. This is the reverse complementary. You knew, right? This is, they have made that. Now this is how Perl is working, and for that you can give us a single sentence, single line. So if you remove this n means, it will come as a single line. And here also, if you remove this n means, the DNA sequences is, it will come as a single line. Okay, you can work out all those files which are I will send to you by mail. Install the Perl in your system and work this, and you get excited. Right, likewise this is sequence display, very basic. See that user Perl, this is the sequence, given sequence, print DNA. Actually this is the first task, initial task, very first beginning. You can and do this. So sequence will be given in the double quote, inverted commas, and it will be printed in a black screen. Okay, and then what about sequence test? This is text, right? See, this is the sequence file. Oh my god, is there sequence text is there? Then I will open, I will show you. This is standard input output PL, which means you can ask user to uh, give an input. This is the file, user as usual, and most probably most of the programmers use strict, use warning, these two lines, right? Use strict means whatever the default. If you want to reduce the error or omit the error means you can use strict word. Otherwise you need not to use strict. You can omit this. Print what is the weather like outside. This is the first line will be printed, and the next chomp change chomp this deletion my weather equal to standard input. So in the black screen my weather equal to will be printed, and this is the space. You can give any string or number like that. Okay, this is user getting response from the user. You can use standard. Again, you have to apply this, go through keenly, observe this, and you have to apply, right? This is most important thing. By using this program as a basic one, you can apply into the sequence, get the sequence from the user, and give the number like that. The question will be like that. So you can use stdin. So say user will give you the sequence, they will type the sequence, or you can yourself type the sequence and go ahead, right? So this is standard input file, and this is trans file, open with notepad, and this is transform the DNA into uh, RNA sequence. So sDNA equal to this much, the sequence will be given to you, or you can type in the text file converted into PL, and then print DNA sequences is, you can print this. And the thing is RNA equal to DNA. So we assigned RNA equal to DNA, but the DNA differs with uracil, right? So we have to give RNA equal to this operator, substitute all the T into U, and here is G is the global one, right? This will be go for search and substitute up to the entire document. That's why we use G here. And here is RNA sequence, this RNA, right? So you can I cannot mail .pl file I will mail you .txt file, and you can edit that. You can just go there and edit the file extension as .pl and execute, okay, as a homework. First you can execute all the file assets whatever I have given to you, and next you try your own, okay. Now I will show you how sequence.txt, then control C. This is, so I have write the all the uh, codes, all the commands for protein sequence to open. This is the command to open this file. This is the file. See that this is the file I have downloaded from NCBI of the sequence file. I want to open in the Perl, so as a file, right? So I have write a code for that, protein sequence code. See that user bin opened. I have assigned the name, file name. After that, print, there is a protein. Just go and observe all those things and run. I just show you the both I need, right? So I have copied the both files into the documents. So sequence.txt and protein.txt. Sequence.txt we can leave as such, but protein sequence, so which one has command? We have to change. This is no command, so you can leave as such, but this thing has command, so you can change the extension into pl .pl, enter. So now we open the what is that, closed I think. Open. Now you can open the file name called, what is that, protein sequence.pl, plot seq.pl. See that read line on closed file handle protein file at C users, PL line 15. Here is the protein, so protein is not opened, so I have to change. Oh, this is sequence.txt, right? And given I have faster.txt. This is, and the error we frequently we will make like that, right? See, sequence.faster, but I have given sequence.txt, so I can enter into .txt and save this. Go there. Now we can try to open that plot sequence.pl. Just enter. See that exactly opening. So machine will not have make errors. Okay. So this is how you can open the file. You can see whatever in the file. This is about Perl basics. All the best. Practice well and paste all the results in your protocol, which means in the manual, lab manual. Thank you. See you again.